My name is Alper Kilic and I'm a PhD student at Tufts University working with Professor Valencia Koomson. My research is miniaturizing a frequency domain near-infrared spectroscopy device, fdNIRS for short. So there are some non-commercial fdNIRS devices available for research groups that are quite large in size and expensive. However, we are working on making it small enough to be like a battery operated hopefully in a credit card form. fdNIRS is a technology that uses time-varying light in near-infrared spectrum to non-invasively measure the absolute concentration of oxygenated and deoxygenated hemoglobin in tissue at the same time. The main difference of this technique than continuous wave near-infrared spectroscopy, such as in common pulse oximeters that you can buy, is that light is time varying, which lets us measure an optical property of the tissue called reduced scattering coefficient that continuous wave near-infrared devices have to guesstimate. This extra information allows us to measure the absolute concentrations of oxy and deoxyhemoglobin, but continuous wave devices can only measure the ratio of these. Basically, what we are trying to do is we are trying to measure the oxygenation levels in tissue without drawing blood or anything. One of the most exciting questions in fdNIRS is that we can measure the hemoglobin concentrations, but what else can we measure? So for example, bilirubin concentration, non-invasively measuring bilirubin concentration can greatly help NICUs for neonatal jaundice cases all over the world. Right now, as far as I know, they have to draw blood periodically and send it to the lab to get the bilirubin, to measure the bilirubin levels, and it has to be constantly monitored. A non-invasive, quick and resource-free in terms of without using any chemicals in a lab way of measuring bilirubin would be a great improvement around the world. One future use would be so we are basically measuring blood hemodynamics using light, and this is if we can measure many other different chromophores using a similar technology, this could actually make the sci-fi trope of diagnosing patients with with moving a probe on them basically real. That would be pretty cool.